today's lesson is on negative exponents. As usual, there is a video guide to go along with this lesson. If you have not printed that video guide yet, go ahead and pause the lesson, print the video guide, and then please come back. That way you can do the examples with me. So today is on negative exponents, which is a new topic for us. Before we get into what negative exponents are and what they do, we're going to go ahead and review what an exponent is, and then we're going to use patterns to help us figure out what a negative exponent does. Okay, so first we need to talk about what is an exponent. An exponent is just a small number in the top right corner that tells you how many times to multiply the large number by itself. Okay, a small number in the top right corner. Okay, so it's going to be, I'll give you an example, 5 to the second power. So this 2 is the exponent. It's a small number in the top right corner that tells you how many times to multiply the large number by itself. Okay, this does not mean 5 times 2. Okay, if they wanted to write 5 times 2, they would put 5 times 2. Okay, this is no better than that one. All right, exponents is a way to shorten or condense repeated multiplication. Okay, so what this actually means, 5 to the second power, is just 5 times 5, which our answer would be 25. Now this doesn't seem much shorter than 5 times 5, but let's think of it another way. Let's do 3 to the 6th power, okay, and just rewrite this. So 3 to the 6th power, that means we're multiplying 3 by itself 6 times. So that's 3 times 3 times 3 times 3 times 3 times 3. I'd much rather write 3 to the 6th power than write 3, 3, 3, 3, 3, 3, okay? It's a shorthand way of writing repeated multiplication, and that's just to the 6th power. Think of it as if we were using 3 to the 21st power or 4 to the 115th power. It's just going to save a lot of space to be able to write it as an exponent instead of writing all of those 3s or all of those 4s or whatever number your base, this is called the base, whatever base you have, okay? So it's a way of writing repeated multiplication. So 3 to the 6 just means you're going to have 6 3s that you're multiplying together, okay? Which is much different than 3 times 6. If we actually work this out, 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. 81 times 3 is 243. And 243 times 3, this is stretching my brain a little bit. So multiplied by 3, we get 9, we get 12, carry the 1, so it's 729. Whew! Much different than 3 times 6 is 18, okay? So please don't get that confused. 3 to the 6th is multiplying 3 by itself 6 times. We're getting 729, not 18. Big difference, okay? So that's what an exponent is. That's the basic exponents. Now what we're going to do is take a look at some 2's, all right, to raise to different powers. And we're going to see if we can see a pattern of what's happening to help us figure out what negative exponents actually are, what they actually do. So we're going to start with 2 to the 3rd power, okay? I want to point out before we actually calculate these that the exponents are going down each time. We got 3, 2, 1, 0, -1, -2, -3. This is a pattern, okay? A pattern is something that you can follow and you'd be able to guess what the next problem should be. If you see the pattern, they're all going down by ones, you would be able to guess that the next one is 2 to the negative 4th. The next one after that would be 2 to the negative 5th, 2 to the negative 6th, so on, okay? So again, it's a pattern because you can see what's going to happen next. Math is all about patterns, okay? There's patterns in all different types of problems. If it doesn't follow a pattern, it probably doesn't work. So you did something wrong, okay? But math is all about patterns. It follows a pattern of rules, and we're going to use that pattern to help us figure out what negative exponents are. So let's take a look at 2 to the 3rd. Okay, 2 to the 3rd power, remember that means 2 times 2 times 2. So it's not 6. 2 times 2 is 4. 4 times 2 is 8. So 2 to the 3rd power is 8. Okay? Let's calculate the next one. 2 to the 2nd power, that means I have 2 2's. So 2 times 2 is 4. So this is 4. 2 to the 1st power means I only have 1 2, which means my answer is just 2. Now, 2 to the 0 is a little tricky, okay? So let's talk about that one. See if we can see the pattern before we actually write down our number here, okay? So, looking at this, we know our numbers are decreasing. And decreasing usually means that we're either subtracting or dividing. So I'm going to start with subtraction and see if I can find a pattern using subtraction. If not, I'll go back to division, okay? So 8 to 4, if I use subtraction to get from 8 to 4, I would have to subtract 4. So I'm going to follow that pattern and see if it works to get my next answer. To get from 4 to 2, if I subtract 4, 4 minus 4 is 0, not 2. So this is not a pattern of minus 4. Because it did not work. I'm already finding a mistake here, okay? And if it doesn't follow the pattern, then that's not the pattern and we need to look for something else. Okay, so subtracting 4 doesn't work. Let's try division, all right? So if I look at this problem, 8 to 4. If I want to get from 8 to 4 using division, I would have to divide by 2. Okay, 8 divided by 2 is 4. Well, let's check and see if that works for my next one. 4 divided by 2 is 2. It worked again. All right, so my pattern is dividing by 2. If it works for both of them, it's going to work for all of them, okay? So dividing by 2 works here and here, so that's the pattern I'm going to follow to find out what my next answer should be. So 2 to the 0 power, if I follow my pattern, I need to divide by 2. 2 divided by 2 is 1. Most people want to say that 2 to the 0 power is 0, and it's not, okay? 2 to the 0 power, because we have to follow the pattern, is actually 1, not 0, okay? So 2 to the 0, and this is true of any number. I use 2's because 2's are easier for us to work with and they're easier for us to see what's going on. But it would work for 7's, it would work for 11, it would work for 25, whatever, okay? Anything to the 0 power is 1, always, all right? Let's keep following this pattern. Because my exponent is going down by 1, I need to divide by 2 again. 1 divided by 2. Well, let's write that out. 1 divided by 2. I want this written as a fraction, so I'm going to change this into a dividing fractions problem. So I'm going to make this 1 over 1. This is 2 over 1, so I'm going to change it to a multiplication and flip the second fraction. Remember, those are the rules for multiplying or dividing fractions. To change a division problem into multiplication, you must flip the second fraction. So instead of 2 over 1, we'll make it 1/2. So 1 times 1 is 1. 1 times 2 is 2. This is 1/2. 1 divided by 2 is 0.5, which is the same thing as 1/2. Okay? Not -2. Okay? That is not the pattern here. All right? If I keep dividing by 2, I'm not going to get a negative number. I'm going to get a fraction. All right, let's look at our next one. We have to divide by 2 again. 1/2 divided by 2. Well, this is 2 over 1, so my first fraction stays the same. Change it to multiplication and flip the second fraction. Flip it to 1/2. 1 times 1 is 1. 2 times 2 is 4. So it's 1/4. Again, a fraction, not a negative number. All right, let's try the next one. Dividing by 2, okay? Last one we're going to do like this. Take 1/4 divided by 2, make it 2 over 1. 1/4 times, flip the second fraction to 1/2, and then multiply. 1 times 1 is 1. 4 times 2 is 8. I get 1/8. Now, I want to compare these a little bit, okay? If I look, 2 to the first power and 2 to the negative first power both have 2's in their answer. The only difference is this is a whole number 2. Here my 2 is in the denominator, okay? So 1/2. It's in the denominator instead of a whole number. Let's compare 2 to the second power with 2 to the negative second power. Both of those have 4 in the answer. The difference is 2 to the second is just 4. It's a whole number 4. Whereas 2 to the negative second, the 4 is in the denominator. It made it into a fraction, okay? We still did 2 to the second. 2 times 2, we got 4. But it put it in the denominator instead of making it a whole number, okay? So I want to point this out because I want you to understand fractions and negative exponents go hand in hand. They go together, okay? A negative exponent is converting these into fractions, not negative numbers. Fractions, okay? Two very different things, all right? Lastly, let's compare 2 to the third to 2 to the negative third. They both have 8's in their answer, but 2 to the positive 3 is just a whole number 8. 2 to the negative third is a positive 1/8, okay? The 8 is in the denominator of the fraction. So what this is showing you is that you still do the exponent like normal, 2 to the third, 2 times 2 times 2, we get 8. But if it's a negative, put that 8 in the denominator of the fraction, okay? That is the difference between positive exponents and negative exponents. So that's what I want you to write down for our rule for what negative exponents do, okay? So a negative exponent creates a fraction, not a negative number. Okay, so this is key for what we're learning today. Negative exponent means fraction, not negative number. Now, one thing that I like to tell people to help them understand, or at least to connect it with something so that they can remember it, I always compare negative exponents and positive exponents with negative and positive people. So I always tell them a positive person is like an uplifting person. They're someone you want to be around. So positive is going to be up in the numerator of your fraction, whereas a negative person, they're kind of grumpy, they're down in the dumps all the time, and they kind of bring you down when you're with them. So that's a lot like a negative exponent because they go down to the denominator of a fraction. Okay, so positive person, uplifting, they stay at the top. Negative person, they're kind of a downer, they go down to the denominator. Okay? And now we're going to look at problems or examples together and show you how to rewrite those. When you have negative exponents, rewrite them as positive exponents using fractions. For problem number 4, we have 3 to the negative 1 power, okay? That negative exponent is telling me that this really needs to be a fraction. So the first thing that I'm going to do is rewrite this as a fraction. Any negative exponent means it goes down to the denominator, okay? So 3 to the negative first goes down to the denominator as 3 to the first power, Okay, now I'm going to explain at least how to help you remember that that turns into a 1. So this is how I think about it. When you are in a situation that you're not comfortable and you don't want to be there, you usually have a negative outlook on what's happening, okay? Hence the negative exponent. However, if your situation changes and you go somewhere where you want to be, like for me, I go home and I get to go to bed, then my attitude completely changes and I'm positive and I'm happy and I'm content and I can go to sleep. So, same thing goes with these exponents, okay? It's kind of a silly analogy, but hopefully it helps you remember. The negative exponent is where it doesn't want to be. So if I move it to the denominator of the fraction, then it's happy, that's where it wants to be, and it becomes a positive exponent. Now, anytime you have a fraction, you must have something in the numerator. If there's nothing there, you put a 1. Just like every whole number, like the whole number of 5, has a denominator of 1, we just don't write it. Every fraction must have something in the numerator. If it doesn't have something, you must write a 1, okay? It's not quite like the denominator where you can leave it off. You have to put something in the numerator, so put a 1 there. So this is 1 over 3 to the first. If I simplify 3 to the first power, remember, any number to the first power is just that number. That means there's 1 3 there. So this is actually 1/3. 3 to the negative first power is the same thing as 1/3. Let's take a look at problem number 5. We have 2 to the negative 5th. That negative exponent means it's down, okay, does not want to be there. So that means we need to put it down in the denominator. So I have my fraction. I put 2 to the 5th in the denominator. It becomes positive once it's there because that's where it wants to be, okay? We have to have a placeholder at the top, a placeholder of 1. Okay. From there, I can simplify 2 to the 5th power, okay? My 1 stays the same, but I know that 2 to the 5th actually means I multiplied 2 by itself 5 times. So let's go ahead and multiply that out. 2 times 2 is 4, times 2 is 8, 8 times 2 is 16, and 16 times 2 is 32. So I would have 32 in my denominator. So 2 to the negative 5th is the same thing as 1/32, okay? Again, a fraction, not a negative number. Number 6, 4 to the 3rd power, okay? Sometimes they're going to throw in problems where there is no negative exponent. I don't need to make it a fraction here. I can just do my multiplication. I can do my 4 times 4 times 4. Well, 4 times 4 is 16, and 16 times 4 is 64. So my answer, no fraction, is 64. Because the exponent is positive, it is a whole number. So it's the whole number 64, no fraction involved. All right, let's look at our last one, 6 to the negative 3rd. This time we do have a negative exponent. So if you have a negative exponent, that means make it into a fraction. Okay, so here's my fraction bar. 6 to the negative 3rd is down, so it goes down to the denominator. Once it's where it wants to be, make it a positive. Okay, so it's 6 to the positive 3rd once it's in the denominator. Okay, always have your placeholder of 1 at the top if there's nothing else there. And now we can actually multiply it out. 6 times 6 times 6. So 6 times 6 is 36, and 36 times 6 is 216. So this is 1 over 216. This is the same as 6 to the negative 3rd. Problem number 8 is a little bit different. We have 6u to the negative 4th, v to the negative 4th. We're now adding variables into the problem. Variables with exponents work the same way as numbers with exponents. Okay, the only thing here is that each part of my term I'm going to look at separately. Okay, so they all stand alone. The number is we think of the number as being by itself. Okay, this letter, look at it by itself, look at the v by itself. Okay, so look at them separately and figure out where they belong in the fraction. I know I'm going to have a fraction because I see negative exponents. So I'm going to go ahead and put my fraction bar. First, look at the letter. Now, at first glance, I want to say, okay, that goes in the denominator because I see negative exponents. However, the 6 does not have an exponent written. When that happens, it is an exponent of positive 1. It's just not put in the problem. I'm going to go ahead and put it right now so that I remember that 6 has a positive exponent. That means the 6 belongs in the numerator of the fraction. It goes at the top. Positive exponents go at the top. Negative exponents go at the bottom. Okay? So 6 to the positive 1 means it goes at the top of the fraction. So there's my 6. Now I can look at u. This is u to the negative 4th. Negative exponents go down to the denominator of the fraction. So this u goes at the bottom. I'm going to give it a positive 4 for an exponent. Remember, they're negative exponents because they are where they don't want to be. Okay? So once you put them where they want to be, make them positive. That's the main analogy that I can give you to help you remember which goes where. All right? And then lastly, we have v to the negative 4th. Again, negative exponent means it's unhappy where it's at, so we need to move it to the denominator of the fraction. So it goes v to the 4th. Once you've moved it, it's where it needs to be. Make it a positive exponent. This is our answer for problem number 8, okay? We're just rewriting today. We're not solving this out. Okay, there's nothing to solve. We're just rewriting it as a fraction. So it's 6 over u to the 4th, v to the 4th. Let's take a look at problem number 9, okay? We have 6x to the 0, y to the negative 5th. I know I need a fraction because I see that negative exponent. Remember, the 6 has an exponent, it's just not written. So there is a 1 there just to help us remember where it belongs. So because it's 6 to the positive 1, the 6 goes at the top of our fraction. Positive exponents at the top, negative exponents at the bottom. Here comes the trick. X to the 0. 0 is neither positive or negative. So where does it go? When you have a number letter to the 0 power, remember that means 1. If this is actually x to the 0 is just 1, that means there's no letter. It does not exist in the problem. There are 0 x's in the problem. So we don't put x because 6 times 1 is just 6. The x to the 0 means the x is non-existent in the problem anymore. There are 0 of them in the problem, so I don't write them in my answer. So x goes away. After that, we need to work with y. Y to the negative 5th has a negative exponent, which means it belongs in the denominator of my fraction. I need to move it down. It becomes positive once it's where it's supposed to be. So this is 6 over y to the 5th. That's my solution for number 9. For problem number 10, again, look at each one separately. I know it's going to be a fraction because of my negative exponents. The 2 has a 1 there. They just didn't write it. So that 2 belongs in the numerator of the fraction. X to the negative 2nd belongs in the denominator. Once you move it, make it a positive 2. Y to the negative 2nd also belongs in the denominator. Once you move it, give it a positive 2. This is my solution. That's all there is to it. Anything with a positive exponent belongs in the numerator. Anything with a negative exponent belongs in the denominator. Let's take a look at one more problem, number 11. 5x to the 3rd, y to the negative 6th. I know I need a fraction because of my negative exponent. Look at the 5. There is a positive 1 there. They didn't write it, which means 5 belongs in the numerator at the top. X to the 3rd also has a positive exponent, so it also belongs at the top of my fraction in the numerator, x to the 3rd. Y to the negative 6th has a negative exponent, which means it belongs in the denominator of my fraction as y to the 6th. And that's our solution for problem number 11. 5x to the 3rd over y to the 6th. At this time, go ahead and pause the video. I'd like you to try the next 4 problems. So 12, 13, 14, and 15. Work those 4 problems out and then come back and check your answers with mine. For problem number 12, I wanted to make sure that I made this into a fraction because I saw the negative exponent. So the 4 has a 1 there, they didn't write it. So because it's a positive 1, I put the 4 at the top. I put x to the 6th at the bottom. Once I moved it, I made that a positive 6. And then I left off y to the 0 because that means there's 0 y's in my answer. So I didn't even put y back in the problem. So 4 over x to the 6th should have been your answer for problem number 12. For problem 13, 3x to the negative 4th, y to the negative 4th. That 3 has an exponent of 1. They didn't write it, but I put it at the top because I knew it was a positive 1. Over x to the negative 4th, and I made it x to the positive 4th, and I made y to the positive 4th once I moved them to the denominator. Because they both had a negative exponent, they both moved to the denominator. So it's 3 over x to the 4th, y to the 4th for problem number 13. For problem 14, we went back to just the numbers. I have 5 to the negative 1. Again, a negative exponent means it goes to the denominator of the fraction. Because there was nothing at the top of my fraction, I put a 1 in the numerator. 5 to the first power is the same thing as just 5, so my answer is 1/5. And then lastly, for problem 15, 2 to the negative 2nd. That means it goes in the denominator of my fraction as 2 to the 2nd power. I had to have something in the numerator, so I put a 1 there. I simplified 2 to the 2nd power. I got 4, so 4 goes in the denominator with the 1 on top. So our answer for number 15 is 1/4. And that's the end of our lesson on negative exponents.